Today we're trying to figure out what the age structure of our forest is here on campus. So last week we went out and took some samples from trees. We used a chainsaw to cut some discs out, and we used increment borers on living trees to take small slivers of wood. And now we're going to figure out how old these trees are and look at their growth rate over their entire lifespan. From here to here is 2012. Here's 11, there's 2010. When we're done, we'll have a better idea as to how the forests were disturbed. For instance, we might find from the tornado of 1974, any of the surviving trees grew really large rings afterwards because they had great conditions. Well, we want to see if there's other events like that in the tree rings and how past droughts affect them. For instance, if we were lucky enough to get to the 1930s with some of these, we might be able to see some of the Dust Bowl events. And there were 79 rings on this tree, which is kind of amazing, I think, for how little it is. Now this week we're going to go ahead and actually try and assign years to each of the individual tree rings so we could see how old they are. So we'll do that by counting them and by pattern matching using skeleton plots and cross-dating. Idea when it died. If we're good, we'll have actual dates on the rings of this. Cross-dating is a process where we match the growth patterns of small and large rings among different trees. So if we're unsure if we've assigned a year correctly to an individual tree ring, we can check across all of our samples and say, for instance, is 1972 small in all the samples? Well, if we find that it was, except for one sample, we might need to relook at that sample and make sure we dated it correctly. And to help us with that, we use paper skeleton plots, where we sort of graphically show how severe the reduction in growth was each year just by making a pencil line on an individual strip of graph paper. Each step's necessary so that you end up with good quality data, because they're going to be used to sort of help us understand the direction of growth patterns for the future. So if we have a good idea of how trees are growing, we can sort of predict what could happen in future drought events or something like that.